A capacitor is a device used to store energy by the accumulation of charge between two conducting plates. What does that look like? Let's start by drawing two conducting plates. We will use these conducting plates to store charge. One of these plates will be used to store positive charge, and the other plate will be used to store an equal amount of negative charge. Let's place our first charge on the plates. So we'll place a positive charge on the positive plate and an equal amount of negative charge on the negative plate. We know an electric field will start on the positive charge and end on the negative charge. So by assembling these two charges together, we've established an electric field between the plates. Well, let's call this pair of plates a capacitor. So these pair of charges establish an electric field between the capacitor. Now, an electric field is also established outside of the capacitor, but right now we'll ignore that because the electric field outside will be fairly negligible if the capacitor plates are close together. And in fact, let's go ahead and signify the distance between the plates. Right now, we will say these two plates are a distance of d apart. We know that when we have a pair of point charges, an electric potential energy is established between them. So for the potential energy established between these 2 point charges we have illustrated here, let's just call that potential energy just U1 for our first pair of particles. And let's keep track of the total potential energy that is stored on our capacitor. Let's add another pair of charges. Positive charge to the positive plate, a negative charge to the negative plate. We know an electric field will be established between the two. That additional pair of charges will also increase the potential energy of our capacitor system. So now we've just doubled the potential energy of our capacitor, just by doubling the amount of charge we're storing on the plates. Let's add a third pair of charge, a positive on the positive plate, a negative on the negative plate. The electric field is established. We have a storage of electric potential energy, and so let's add to the total potential energy of our capacitor. Now, this is a qualitative discussion. I should point out that it's not just the electric potential energy between those two pairs of charges I just added, but rather the electric potential energy of the system. There is a number of charges that are all sharing potential energy, and in fact, there are 6 charges right now, all potentially sharing electric potential energy. For simplicity, we're just going to focus on the potential energy shared by pairs of charges, so we could focus on the essential aspects of the concepts of a capacitor. And for now, what you should be getting is each time we add a pair of charges, the potential energy of our capacitor increases. So from our initial potential energy using the first pair of charges to now, we've increased the potential energy stored by the capacitor by 5 times. We've also increased the electric field of our capacitor by 5 times. So this is what a capacitor does. By accumulating equal amount of charge on 2 plates, one plate holding the positive charge, one plate holding the negative charge, So this capacitor establishes an electric field between the plates. And you know that since there is an electric field, then there is an electric potential difference between the two plates of our capacitor. So not only does our capacitor store potential energy, it establishes a difference in potential between each of the plates because we have a separation of charge. A separation of charge where one plate is the positive plate, the other plate is the negative plate. And if we can maintain this separation of charge, then we will be able to maintain a change of electric potential, which allows us to maintain a potential energy in the capacitor. Putting all of this together allows us to say that a capacitor is used to store potential energy by the accumulation of charge between two conducting plates.